Today we worked on Chapter 3, Section 1, and did a little review of some of the conversations we'd had before about simplifying fractions, but more on that in a minute. And we talked extensively about the idea of a least common multiple and how we use least common multiples. In a nutshell, how do we use least common multiples? We use them to determine the lowest common denominator when we are adding or subtracting fractions. And in order to add or subtract fractions, you must have the denominators to be the same. The name of that is like fractions. That is, two fractions that have equal denominators are referred to as like fractions. Obviously, if they do not have equal denominators, they're referred to as unlike fractions. We did a brief review of the concept of the greatest common factor, and I only did this because I wanted to be able to contrast the idea of a common factor with a lowest common multiple. We did a review of how do you determine the greatest common factor. You use some factoring to determine what the greatest common factor is. Here was a simple example. We had 8 30-seconds, and we started off with a factor, full to prime factorization. And if you carefully notice, the factors that were canceled out here are 2 times 2 is 4 times 2 is 8. 2 times 2 is 4 times 2 is 8. So that is the greatest common factor. And we could, in fact, simplify this in steps by using the factor of 2 repeatedly. Or if you used 8, you can factor it in one step. The idea with the greatest common factor is it allows you to simplify a fraction faster once you start the simplification process. Now, the idea behind the lowest common multiple, an analogy to use is this analogy. And if you had some money, and I just drew these diagrams, if you had 2 quarters, 2 nickels, a dime, and 2 pennies, and someone asked you, well, how much money do you have? And you told them, oh, I have 2 quarters, 2 nickels, 1 dime, and 2 pennies. Altogether, I have 7 coins. And they ask you again, how much money do you have? And you tell them again, 2 quarters, 2 nickels, a dime, and 2 pennies. And they're going to say, no, that's not what I'm asking you. How much money do you have? Obviously, what they're asking you to do is they're asking you to convert 2 quarters to 50 cents, 2 nickels to 10 cents, a dime to 10 cents, and 2 pennies to 2 cents. And you add that together and you get 72 cents. So what have you just done? You've just converted to the lowest common denominator, which is 100. Why 100? Because our denominational amount for $1 is 100 pennies. And these are amounts that would add up. If you had enough, you'd add up to 100 pennies and you'd have a full dollar. So we would say that this is 72 cents, or 72 out of 100. So we've done that pretty much all of our lives when we've tried to count money. Now, when you are working with fractions, here's an image that may help you. Let's say you had these 2 fractions, 8 30-seconds, which we've already simplified, and we had 6 ninths, and we just simplified it there. If I wanted to add these 2 fractions together, first thing I might do before I tried to attempt any fraction manipulation to get a common multiple is I might try to simplify them. And if you can simplify them first, your calculation of your lowest common multiple will be easier. So we simplified these 2, and then I drew this diagram and said, well, what I have here is I have 1 out of 4 and 2 out of 3. And the dilemma is, how much do I have? 1 out of 4, 2 out of 3. 1 out of 4, 2 out of 3, which is the same situation I was in a minute ago when I kept describing my money as 2 quarters, 2 nickels, a dime, and 2 pennies. What we need is a common denominator. What is the common denominator? Now we know what the common denominator was with cents. We saw that a minute ago. Notice you can use common multiples, and you say, well, here's 3, start multiplying by whole numbers. Here's 4, start multiplying by whole numbers. And what are 3 and 4? They're these different unlike denominators. Notice simplifying the fraction gave me smaller numbers to start with. I could have started with 32 and 9, and we would have reached a conclusion, but if we can start with a simplified version of this fraction, we're going to get an answer that is going to be easier to determine. So at any rate, you start multiplying by whole numbers, and you find that the first common multiple you discover is 12. Now there is another common multiple close by, which would be 24. And if I multiplied 3 times 8, I would get 24, and 4 times 6 would give me 24. But I will use 12 because when I change my fractions from fourths and thirds to twelfths, I'll have a much easier job to simplify. As a matter of fact, I might not have to do any work at all. In this case, we converted 1/4 to twelfths. How do we do that? We multiply by 3. Remember, what you do in the denominator, you do in the numerator. I'm making an equivalent fraction here, and we've done some of that before. Same idea here. So this becomes 3/12 and 8/12, and I add together and I get 11/12. If this were a subtraction problem, and let's say that I wanted to subtract 1/4 from 2/3, then I would have to do the same common denominator work to accomplish that subtraction. Now, other techniques exist rather than the idea of using a table of common multiples. And so here's another example where we had these 3 fractions that we wanted to add. They are unlike; they do not have the same denominator. So we use first the table of common multiples. All right, so 3 times 1, 3 times 2, 8 times, you see what this is doing. I'm just taking these values for the denominator and multiplying them by whole numbers. And the first common multiple that we discover is 24. Therefore, it is our lowest common multiple. And that's the value we will use when we create our equivalent fractions below with denominators of 24. Now, an easier way to do this is to use factorization. How does that work? You factor each of your values, denominator values, into prime numbers. 3 is a prime number. 8 is 2 times 2 times 2. 12 is 2 times 2 times 3. So these are all prime number factors. Then, and this is the sequence, and there's a slide that describes this in the PowerPoint slides in Math Excel. I use each of the factors that occur here. I use each of them the greatest number of times they occur in any one factorization. So you look, 3 is here. It's not here, but I'm going to use it because it's here. It's here 1 time. So since it only occurs 1 time, it's used 1 time. 2 is not in this one, but it is here. Here it occurs 3 times, and here it occurs 2 times. So I'll use it 3 times. You multiply those together, and you get 24, which is the same conclusion we reached up there when we used the common multiples. Then what did we do? Well, we said, what must I do to 3 to convert it to 24? Multiply it by 8, and I use 8 in the numerator. 2 here, 2 in the numerator, 3 here, 3 in the numerator as well. Now, sometimes it's not easy to tell, starting with this and getting to that. It's pretty easy for us to tell when we multiply 8 times 3. The methodology for doing this is, it's a little complicated, but the methodology is you say to yourself, all right, what are the factors that are in the lowest common multiple? 2 times 2 times 2 times 3. What are the factors in 3? Only 3. Therefore, what factors that are in the lowest common multiple are missing from 3? Well, it's 2 times 2 is 4 times 2 is 8. So that's where the 8 came from. Likewise, I multiplied 12 by 2. Where did that come from? What factors are in the lowest common multiple that are not in 12? Okay, so we have a 2, 2, 2, 2, and a 3. So 2 is the missing factor in the multiple that's not in 12. And so that's where the 2 came from, and likewise over here. Then you just simply, remember, you keep the denominator once you get the common denominator, and you do the arithmetic on the numerators, just add them together. Now, we will, the next class, discuss the fact that this is an improper fraction, meaning if it takes 24 to make the whole, and I have 47, it's pretty obvious I can convert some of these to whole units, right? How might you see that? Well, what if you saw it this way? What if you said, well, I think I'll start with 47, and I'm going to take 24 of those, and then how many was left when I took the 24 from the 47? So this is 1 and 23/24. So what did I do? I said, this is 1, and here's the ones that are left over. And so this fraction and this fraction, actually it's called a mixed number, since it has a whole number component, are equivalent to each other. This one is just, everything's in pieces, and this, I've put some things together. It's just like, if you go back to my money example, let me add some money to my example. I don't know. Let me add another 25 cents, another 10 cents. So now what do I have? Well, this is now going to be an additional 35 cents. Yes. So that's an additional 35 cents. I had 72 cents. Altogether now I have what? I have 107 cents. 72 and 35 is 107. What is that? It's 107 out of 100. Oh, so, this is really $1.07. This is an improper fraction when I leave all the money in coinage. This is a mixed number when I convert. How many of these pennies did I convert to $1? 100 of them, right? So 100 over 100 plus 7 over 100, which gets me back to my total of 107, is $1.07. So I think that's quite enough for today. We will continue to work in chapter 3 next week, and I think that's it today.